All right, so before we get going on lessons today, I need to remind you of a couple of old things that we've had done in the past that are going to come to play today. So let's talk about factoring, okay? Difference of perfect squares. Any ideas? So minus 3x plus 3, cool. So if you get something like this, same concept. Remember, this is a perfect square, that's a perfect square, so 2x minus 1 and 2x plus 1. So that's one type of factoring that you need to remember. The other type of factoring is this. So we talked about fast ways to factor this one and slow ways. Most of you didn't catch on to the fast way. It takes a lot of practice. So this, what multiplies to 1 and adds to 2 is 1 and 1. So this is y plus 1, which you notice, of course, is the same thing twice, so it's y plus 1 squared. Okay? So I say there's a faster way to do this. That's pretty quick, but there's a faster way. If you notice that the same number, if this is 2 times a number and this is that number squared, you can factor x minus 4 squared pretty quick. Now, you can do it a little bit slower. What multiplies to 16 and adds to negative 8, minus 4, and then you get minus 4, and you write it twice. But if you recognize the pattern, it goes real fast. I say this type of factoring will come up a lot today. But I just wanted to remind you, you can go a little bit slower. I'm going to be doing the super quick way today, so understand it's this type of factoring, and I'll show you what I'm doing. But it's going to come up a lot. All right? So, also, let's remember solving equations. If I see something with parentheses, I don't have to distribute. I can divide by 5 first, and then add 4 to both sides to get the answer. Now, if there's no parentheses, obviously we would just go ahead and work it out like normal. But if there's parentheses, we can divide first before we go through it. Again, I'm not working through all this with you. Just wanted to remind you of a couple of things that are going to come up today and tomorrow. We're spending 2 days on this topic. All right, so the topic we're talking about today is called completing the square. It is another method for solving these quadratic equations that we've been going through. It takes a little getting used to, not gonna lie, but once you get the hang of it, it's not bad. It's very helpful in very specific situations. It's not something you would use all the time, but it is very helpful in some specific situations. So, what does it mean? First of all, let's talk about what does it mean to complete the square. So, ignore all these words and everything. If I had this, and I had this as a square, imagine it's a square. And we haven't done too much with algebra tiles, but you may have done stuff in the past. What's missing here to complete the square? Well, if I imagine these are lines that can't be broken, what I'm missing is 4 little ones. Okay, so when you play with algebra tiles, you have the x squared size tiles, you have the x size tiles, and you have the 1 size tiles. So you see here they completed the square with 4 ones. That's literally what this means. The method that we're going to learn, first of all these methods date back thousands of years, but this was done initially by ancient Egyptians as a way to survey land. Like if somebody had a misshapen piece of land, you would complete the square to kind of figure out the area and then take away the part that you added on. Very interesting technique. So if I had a problem like this, how many would I put here to complete the square? Yeah, so I've got 3 this way and 3 this way, so I'm missing 9 right there. So how can you get that? Well, there's 3 and 3 makes 9. 3 times 3 is 9, complete the square. That's more of a visual representation. We're not going to mess with the algebra tiles, but I want you to kind of understand that's why it's called completing square, because you literally make a whole square by filling in a gap. All right, so algebraically, what are the steps? Write this down. In this form, x squared plus bx, follow these steps. Half of b, find 1/2 of b, the coefficient of x. Square the result from step 1. Add the result from step 1 to step 2. To that, and you're there. So what does that mean? Well, here's b, half of b squared. Result from step 2. So now, algebraically, whatever you do to one side of the equation, well, we'll talk about what this means in a second. Okay? But just understand it's half of this number squared. Just like, how many tiles are there all together? Well, there's 6 tiles. They're facing different directions, but there's 6 tiles. So half of 6 is 3, 3 squared is 9. I used 9 ones to complete the square. In this example, how many are there all together? 1, 2, 3, 4. There's 4 all together. Half of that is 2 times 2 is 4. I used 4 to complete the square. So it's half of the x's squared. So if we look at a problem like this, to complete the square, well, take b, half of b would be 3. 3 squared is 9. So this is plus 9. That's what you need to complete the square. Then factor the trinomial. So now I have this trinomial here, and it's going to factor. Okay? So if I take a look at this, how is it going to factor? Well, what multiplies to 9 and adds to be 6? Yeah, 3 and 3. Notice a connection. Which is the same as x plus 3 squared. So if I want to factor one of these bad boys, when I do the complete the square step, whatever that half was, I'm just going to use it right there. So that half number that we squared to complete is also going to be the same thing. So before we talk about this, let me show you what we're talking about with the images, right? If I have 6 of these x terms, and this is an x squared term, and these are all x's, how long is this side? Well, this is x, and there's 3 of them here, so this is x plus 3. Across here is x plus 3. There's 3 of those. All right? So that's why we can do this pretty quick. Well, what does b look like? Half of this squared. Well, gonna need a calculator on this one. I think it's like 20.25, but it's been a while since I've done this. 9 divided by 2 squared 20.25. So, since I squared, it turns positive. So, complete the square. Completed the square. Factor the trinomial. Don't have to do a lot of heavy lifting here. It's going to be that number. There. Okay? Questions? So, do these 3. So half of this is 5, squared is 25, and it factors to x plus 5 squared. Half of this is minus 2, squared is 4, and it factors to x minus 2 squared. Half of this is 3.5, squared is 10.5, 12.25. And it factors squared. Questions? All right. We are going to stop right there for today. Tomorrow we're going to work on a little bit more, but I just want us to practice that stuff for now. Okay, all right, your assignment's on big ideas. Get them out, get to work.